Hi! Today we're going to be talking about Copernicus and Galileo Galilei. First of all, gravity affects all of us, our height, our posture, shapes our bodies and molds our planets. It's part of our lives. It binds together all the matter in the universe and makes our existence here possible. And probably in ancient times it started with one simple question. What happens if I drop an object? How does an object fall? In this chapter of Gravity, a pathway made by extraordinary minds, I'm going to discover the answer to this incredible question. So let's start. Let's start talking about Nicholas Copernicus. Nicholas Copernicus was an astronomer in Polonia, famous because from his observations he discovered that Earth orbits around the Sun and not vice versa. The data that he collected over the years was published in his book of the revolutions of the celestial orbs, in which he exposed the theory that the stars and planets revolve around the Sun, known as the Heliocentric Theory, in which he affirmed that the Sun was the center of the universe, causing a big reaction in society and in the science of the 16th century, mainly in the Church, because the Church sustained that man, God's creation, was the center of the universe. Also, Aristotle's theory of gravity would crumble, because this Copernicus theory didn't solve the doubt about Aristotle's theory gravitas that said that the gravity affected differently in each body. Now let's talk about Galileo. Galileo was really interested in falling bodies. He began to experiment with falling objects on inclined planes. He is told that he spent many hours experimenting from the Leaning Tower of Pisa, trying to measure the time it took for an object to touch the ground. He was obsessed with pendulum motion and motion through inclined planes. He managed to develop formulas for accelerated motion, reaching the conclusion that gravity was a constant force in all bodies, amending another of the errors in Aristotle's theory. That means he solved the doubt about Copernicus' theory, which was that even if the body is big or little, the gravity affects equally on the two of them. He also demonstrated that all objects fall at the same time. The result of his research appeared in the book El Principio de Equivalencia. Now, let's talk about why a hammer falls first than a feather on Earth. The common answer is because the hammer is heavier, but the real reason is not. It's the air resistance and the shape of the object that affect the fall rate. To demonstrate that all objects fall at the same rate, in 1971, the astronaut David Scott, during the Apollo 15 mission, made an experiment dropping a hammer and a feather on the moon. And what happened? Let's see this video.
Well, in my left hand I have a feather. In my right hand, a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? It proves that Mr. Galileo was correct in his findings.
Okay, so as you saw in this video, he conducted Galileo's famous hammer feather drop experiment on the moon. Well, on the moon there is no atmosphere, it's like a vacuum. So the objects should drop at the same speed as you saw on the video. Galileo was proven right. Now let's see this question. When you drop an object, it falls at a constant speed or speed up as it drops? Galileo Galilei also made this question, but Galileo dropped objects from different heights and found that objects do not fall at the same rate. They accelerate and gain momentum as it drops. He identified something fundamental to all falling objects. They accelerate. But how much? How to measure this? Well, because gravity causes objects to move very, very fast, and he did not have timekeepers good enough to record the time, he used ramps with movable bells to slow down falling objects for accurate timing. This artifact is known as the Galileo Ramp. Galileo found the rate at which gravity speeds up objects, and he found another fundamental principle. You can measure the strength of gravity by how much it causes falling objects to accelerate. A falling body accelerates uniformly. It picks up equal amounts of speed in equal time intervals, so that it falls from rest. It moves twice as fast after 2 seconds as it was moving after 1 second, and 3 times as fast after 3 seconds, etc. His analysis indicated a pattern. The total displacement traveled from the start increased by perfect squares of the time interval. For example, 1, 4, 9, 16, 25, and 36. That was all for this video. Thanks for watching. I hope you enjoyed this video. Please leave a like and also subscribe. And also stay tuned because in the next video I'm going to talk about Johannes Kepler, the man who shattered the myth persistent for 2 millennia that heaven bodies had to move in perfect circles. Bye!